So we're going to be answering the question what percent composition of oxygen is in calcium phosphite. So there's a lot of little pieces to this question. So first, we actually need to know what this is, which also means we need to know what phosphite is. So this is one of your polyatomic ions. So you are supposed to have those memorized. But phosphite looks like this. Calcium, I can at least pull that off of the periodic table and see that calcium is here on my alkali earth metal in the group 2A. So this is going to have a +2 charge. From here, I need to put this together to form an ionic compound. So I can use that drop and swap method. That I'm going to need 3 calciums and 2 phosphites. So here, finally, is my formula to work off of my percent composition. So this is really asking about something to do by mass. So when we're doing this, what we're going to need is essentially the total contribution of oxygen, since that's what the question asked me about, then divided by the total formula mass. Since it's a percent, this will then be multiplied by 100%. So what we need to do first is we're going to go ahead and get that total formula mass. So in order to do this compound, this calcium phosphite, this means that we have 3 calciums. We actually then have 2 phosphites. So this is going to be 2 phosphorus atoms and then 6 oxygen atoms. So I got that really by thinking about the fact that what I have 2 phosphites, which then is going to give me my 2 phosphorus atoms and my 6 oxygen atoms, sort of breaking things down. Then from here, I'm going to use my periodic table. So I'm going to go ahead and pull again that periodic table where I've got calcium with an atomic mass of 40. Phosphorus, there's 2 of those, the 30.97. And oxygen is 16. And my goal is to actually add all of these together. So after everything is said and done, we can get a total formula mass of 278.18. So I've got my total formula mass now. So this is going to be my denominator. Now the other thing I like about doing things this way, what I wanted on the top is that total contribution of oxygen. So by thinking through the fact that I have 6 oxygens and that they're going to have that atomic mass of 16, so my total amount of oxygen then is going to be this 96 number. This then actually becomes my numerator. So what I care about then for this formula is going to be 96 divided by 278.18, and this is the percent times 100. So this is going to be how I get that percent composition number. So after plugging everything into my calculator, I get 34. I'm going to do 0.51%. So for percent composition, again, as far as the mathematics goes, it's just a bunch of addition and multiplication. The main tricks that come up in these problems are things like nomenclature, which, yes, I realize is something different, but you guys do need to know your nomenclature for this. And then just realizing that when we talk about oxygen, we don't just mean a single atom of oxygen. I want to know about all of the oxygens for this particular compound. So it's not just one oxygen out of the total, it's all of the oxygens I have out of the total amount.